All right. So I restarted and I have everything set back up again. I'm not sure if, let me know if the audio is better, because from my point, last time the audio sounded fine. So I'm not sure what was going on there, but hopefully a restart fixed it. Sounds good now? Okay, great. All right, well, bit of a rocky start. Today we're gonna continue the work from Wednesday where we were going over function interfaces. I'm not gonna go through you could earn extra money by telling people to restart their devices. It is like, it's so frustrating that is often the best advice, right? It's just power cycle. I do wonder what was happening. I have like there's some weird interactions I have between some of my devices. I've got like this big powered USB 3 like bank, and that hooks up to the USB-C port in my MacBook. And then I've got also a Thunderbolt 3 dock that's doing a bunch of stuff too. And I don't know, it seems like every time I unplug and plug my computer back in, there's some driver somewhere is confused. So not sure if there's anything I can do about that. But I think for today, I'm not going to go over like all of the background on function interfaces and anything. We'll just pick up where we left off yesterday. But if you're trying to understand more context into what we're doing and haven't seen the stream from Wednesday, that might help out. I did make some progress, so let me pull up a few things here. We had these two tests from before, and this test here tests just a real basic example of a function interface with a composable function. And then this one is basically the exact same test, just the function's not composable. And I ended up, let me pull these things over. I ended up adding something to the function body transformer. Which is here. So I ended up adding this, and what this did was, so basically in this transformer, when we visit a function, we create like a function scope that we hang some metadata off of, and then we kind of, continue traversing the tree. What I needed to do was indicate whether or not that function was a SAM conversion or not. Because one of the things that we do is for composable lambdas, we have like an optimization where a lot of the like preamble and postamble of a composable, like a composable lambda is a restartable composable function. And that means that we have to generate code at like the start and the end of the function body. But it's kind of like the same code for every lambda. So what we ended up doing instead was we created this lambda class that kind of handles a lot of that. And there were some other reasons to do that as well. And so we actually generate less code for composable lambda. But hey Nicholas, good to see you. For a SAM conversion, so like one of these, even though this looks like a lambda, we actually want to generate it won't use our generated lambda class. And so we want to generate all of the code that we normally would in a restartable composable function. And so we need to go down a different path. And so in order to do that, I needed to know whether or not this function was a SAM conversion or not. And the only way that you can figure that out is based on whether or not you're in a function expression that is like a SAM conversion. And so what I did is I added this function, this override, which what it does is it looks to see if it's like a SAM interface that this Lambda is implementing. And if it is, then it just sets up the scope and then passes in true for is SAM conversion. So that's what I did there. And so I thought that would work and be all great. And it does kind of generate sensible IR. But it turns out that seemed to break other things. And so I think something that I'm doing in here is wrong. And it's like proper wrong, even if it's not a composable function. So what ended up happening was if I just run this test, so without any composable anything, it's gonna fail. So now that I just restarted, I'm curious how long this build is going to take, but hopefully it's not too bad. So basically, I'm kind of trying to walk you all through just a little bit of the kind of debugging process that I went through to get to like my current level of understanding, which is a little bit more than when we finished the stream on Wednesday. So I have a pretty good idea of how to fix this. And it basically has to do with this code here, I think. Well, so while it builds, I'll explain what's going on. So, hey, time space being, nice to see you. So this is one of the built-in lowerings in Kotlin. It's function reference lowering. And I didn't see this earlier, or I didn't bother looking at it earlier because I thought that this was just for like the : function reference syntax. But it turns out this handles a lot of the SAM conversion stuff as well. So for instance, like this type of behavior. And so you can see here that when it sees a SAM conversion type operator, it goes through this code pathway. And this is kind of the important bit here that that this goes through. So for like basically this turns a type operator, which is like a SAM conversion type operator, IR node. And the result that it returns is a function reference. Yeah, so interesting. What is this? Build. I see. So the thing that it results in is a block, I suppose. Well, it's an IR expression, but yeah, it returns a block. And so it turns out that we weren't falling down this pathway when I added that code in the function body transformer, and we were supposed to be. So that's kind of like where I currently am, is I need to figure out why that's not happening. And I think it's essentially that this if statement ends up failing. Interesting. I'm kind of surprised that that passed. I thought that it would not. Let me see if this one passes. Maybe that was the thing. Maybe it was only failing for composables. I hate how slow this is. So I'm gonna try and just understand what it is this does. Okay, so it did fail. And so this is the failure that I was seeing earlier. And the problem is that it fails like pretty late. You can see that what happens is it ends up saying unhandled intrinsic. And let's just go here. So I ended up with this error. So basically callee.parent is not an IR class, and callee here ends up being the function expression. No. The function, I think. Anyway, I was kind of confused about like what was going on here, because I was like, okay, this is visiting a function access expression, and you know, the parent seemed correct, like it, you know, it was like it seemed like the right parent, and so I wasn't sure why we got in here. And then I basically started looking for places where the function interface was, or like the SAM conversion function interface stuff was used. And so then I found this single abstract method lowering where you know, it handles this. So basically if it runs into a SAM conversion, then like it runs this code. And so I was thinking, okay, this is where SAM conversions are handled. But what I found out was that this code doesn't execute when for the test that passes. So if I run this test, then this code never executes. And so then I realized, okay, I need to find out where else SAM conversion is used. And then with that, I ran into the function reference lowering. And I'm now pretty confident that this is where sort of the magic is happening. And you know, that's what we're gonna find out right now. So this test is now failing. And what I want to do is I know now that well, actually, let's verify that first. So what I believe is that this code will get executed in this test, in the non-composable test. And so let's first verify that that happens. And if it does, then what I need to make sure is that it also gets executed for the composable version. And if it doesn't, why not? Am I running the wrong test? Yeah, I am. It's the inner class. I don't want that. Okay. I'm worried that these aren't getting like the little check marks. So I do want to understand more about what this is doing. Okay, so here we are. And so let's just look at expression here real quick. So expression, this is a type operator. So this is a SAM conversion operator, and the argument is, it's a lambda. And lambdas in IR are represented as a block with a function and a function access expression. Or a function reference. And so this is what we expect. And the first one, this is like our lambda class, or our lambda function, and then this is a function reference to that function. So then basically that just, in the eyes of IR, that just looks like a normal lambda, but it's wrapped with this type operator, which then it says the type operand of this type operator is that it's a class of interface A. And so that's basically the conversion, is that lambda gets converted into A. And then I believe this is where that change ends up occurring. So let's, so then by the end of this, instead of being a type operator, it'll result in just a function reference, just basically something of the same shape as the argument here, which is it's a block with a function and a function reference. So I think it's gonna end up in here. So invocable is gonna be a block, that makes sense. And it'll have a lambda origin and be an IR function reference. Okay, so that all makes sense. And then I've got another breakpoint set. Actually, I want to stay here. So I think what's happening is I'm ending up in this else block in the composable case, which means that the SAM conversion stays in the IR, and we want to get rid of it so that it doesn't end up in that other pathway where we were running into the exception. Okay. Okay, so here we're building the class. That all makes sense. And then I kind of want to see, okay, so this is where we build. This is the expression that gets returned, which is in IR block. And the block has the class and then a call to the so what does a function reference normally have? Yeah, okay, so like a function reference yeah, a function reference it's kind of like a call, I guess. You can think of it as like the construction of the Lambda class, I guess. Okay. So I don't think I need any more information from here. Now what I want to do, so that was running the non-composable variant. So now what I want to do is run this one. So I don't care about that. Andre says function reference gives you function type while not calling it, so it is closer to what you'll do with a : compute. Yeah, so you can think of it like the creation of a lambda, basically. But that, so the a : compute, like that's what I thought. I thought that function reference lowering was only going to handle that syntax, and I didn't realize that SAM conversion, like we're doing with this call, like in this test here, I didn't realize that would fall under the same lowering pathway. So, okay, so I'm guessing that this is gonna return false. So invocables, this IR block. So this. So maybe it won't. So invocable. Dot origin dot. Okay, is lambda returns true? So actually I think it will go down this path. That's kind of weird. So what just happened there? Function. So I think it hit a different Interesting. Like, so inside of this transform, it ran into this, and I feel like it didn't last time. But maybe it did. I don't know. It just seemed like I had that breakpoint there. So I think we want to find out if that one gets hit the other times as well. So I'm confused. Let's see where... Like, is this the same thing? Function for lambda. Oh, maybe this is the... I see. So this didn't get hit last time because this is our synthetic lambda that we've added to the body of the function. So this is fine. So we should still end up here, basically. Yeah. All right. So I wonder if these symbols don't match up. So like this is a function reference to that symbol. So this should match up with this 11490, 11490. Okay, so that's the right symbol. All right. So I mean, I think something wrong happens inside of here. So I'm just gonna like step through carefully. So in this case, the supertype should be A. Yeah. And we've got the right function reference. You say, I mean, I think we do. Okay. Like, I wonder if it would be better for me to override visit type operator instead of the visit function expression in here. That might be the better thing to do, because then instead of using this is like kind of a squirrely condition here. Instead I could just use if origin is SAM conversion, which that makes more sense, I think. All right. So the font is Dank Mono. If you go to dank.sh, you can find more information about it there. All right, so we initialize a bunch of stuff. So is lambda is going to be false, Kali is going to be null. That's a little bit weird. There's the link if hopefully that works for you. I see. So those were the default values. So Kali is this IR function. And this is the transformed function, so that's good. All right, let's just keep going here. Current. Okay. So what else was added here? Oh, where am I? This is so parameter types, there are 4 of them, which makes sense. So it should be or does it make sense? This is int, right? So it's int and then composer and another int. What is this? Oh, unit. Okay, I guess it's like it wants the return type as well. Is Kotlin fun interface? So that's true. It's good. So now this is the class. Yeah, I bought the font a few years ago. I mean, everything actually looks correct, so I'm not really sure what to do here. Is lambda true? Yeah. So let's go ahead and see what happens inside of build. We've got a constructor. There's no receiver. So we're not going to generate these. Need to generate SAM equals. So this should happen. So add fake overrides via incorrect heuristic. Okay, I don't know what that is. Weird. So, I mean, it seems like these are just implementing the, you know, hash code and to string and stuff like that, but I'm not sure what's the incorrect heuristic about. It's a little bit weird, but sure. Okay, and so then we just have a block and it's got the function reference class. So this is a new class, and then this call to the constructor. And that all looks super correct. So I'm a little bit confused here. So if we go to the place where the error occurs. So this is going to happen again. But I'm not really sure why. Okay. Let's just continue. So, this expression so what is this exactly? This is the So this is a call to the Lambda. Which is it. Oh. Okay. I see what's happening. Okay. So let me explain what's happening, because I think I know now. This is the let me just make sure. So pass in composer. Yeah, and that's the value parameter. And then this is an OR with 1 and the changed arguments. Value 1, yeah. And captured changed, yeah, okay. So this is what's happening. All right, so right now, when we have this code, or like, let's just say this code, what we transform this into is example with, essentially the same thing passed into it. So like, we want to try and have all of the SAM conversion stuff happen. Like, we don't want to write all of the SAM conversion code ourselves. That's already handled in the IRA compiler. And so what we want to do is we want to write the equivalent as if, compose didn't exist. And so what that looks like is if, basically if this composable annotation went away, and then this became like a function that had these extra parameters in it. And so if we wrote that code, then this code, it would just look like this, except we would have like a it composer and changed, and then this would get the composer passed into it, and then like some other number passed into here. And so that's kind of the idea. That's what we want to, that's how we want to transform this. And then the fact that this isn't a lambda, the fact that it's a SAM conversion, should just be taken care of by the compiler. The problem with that is that when we do that, so this is basically what that looks like, and we generate some other code, but so then we call a.compute, and so all of that looks great. This is exactly what we want. But here's the problem, is that we generate another lambda, and this lambda is a proper lambda, and inside the body of that lambda, it is supposed to call this lambda. The problem is that lambda doesn't exist in the final code. And so what we might need to do is generate another SAM conversion here. No. We just need to be smarter about it, I think. Yeah, so basically the this that is in this lambda should be an instance of A. And I think that we want, so I think we want this to basically be like .compute. I think that's our problem. Well, I know that's the problem. I'm just not sure what the solution is yet. So, okay. So we're basically doing mostly the right thing. It's just this lambda that gets generated that's the problem. Okay. That makes a lot of sense. So I kind of want to update some of this. Instead of visit function expression, I think we should do, let me just stop the debugger here. I think we should visit type operator. And then we'll say if expression dot origin. Why is oh, it's operator equals higher type operator dot SAM conversion. Okay. So if it's not a SAM conversion, we don't really care. And then we're gonna do something like this, but just in here. Because most function expressions we don't actually care about. They already transform properly. It's these that we care about. So we're gonna kind of write code similar to this up here. So we'll get the invocable. So I wonder if these cases happen, and if they do, then do I care about them? I'm just gonna keep this else and all that stuff here. I think that seems fine. So this is what I care about. So this ends up being the reference, which is okay. What I want to do is grab the function, and the function is going to be the first block here, I think. I mean, it does this drop last thing, but I don't actually, I think there should never be more than 2 here. So what I'm gonna do is just do invocable statements dot first as IR function. So this is our function, and then we're gonna say scope function is true. And actually, I mean, so maybe instead of just is SAM conversion, what we want is the SAM type. So if I do this, IR type equals null, SAM conversion type. How about that? This is kind of a weird property. I'm not sure I like the way this is working out. Might want to change that, but let me see, where did I use this? So I used it here. So basically now I want to say if SAM conversion type is not null, then we're returning true here. Okay, and then where's this code? All right. So now I want the SAM conversion type instead of just true, which that's going to be type operand here. Yeah. And then we're gonna do this stance. And interestingly, I don't really want to I want to keep this I want to keep it a type operator. So like I'm not actually, unlike the function reference lowering, I'm kind of keeping it in its same shape. So I guess what I want to do instead is just say, so I'll just ignore statements.last here. And I'm going to say statements 0. Well, let's just say transformed. then this is going to be function. And I'm not sure if I need to do this, but yeah, I don't actually. And then here I'm gonna say invocable dot statements 0 equals transformed. I can do that, right? What is this yelling at me about? Okay, so I don't care about this branch anymore. So I actually am gonna do this here. And then I don't care about this branch because that's already taken care of here. So I can just remove that. And that's also fine. So maybe here what I want to do is I want to return expression. Get rid of this. Oh, but I do want to transform the function reference. If function is function, let's just do that, and then so do I want this to be a simple function? Yeah. Okay, so I guess I want to make sure that I transform everything in every path. And so I think what we can do is just have this final return. Like we'll just rely on that in every case except for the one we're looking for here, which is here. So inside here, we're effectively transforming the first statement of the of invocable of expression to argument. So then we're gonna just return expression here, but what we want to do is transform the other arguments or the other statements in the block. So we'll say statements dot drop 1, and then for each it dot transform this null. What is this complaining about? Sure. Wait, what? Statement. Why is this still complaining? Replace with repeat. No, I don't want to do that. I'm using the... I feel like this is a weird suggestion. Okay, so that takes care of all of those transforms. And then if any of these else's go, we're gonna end up down here and we're just gonna transform like normal, which seems fine. Return should be lifted out of if. No, I feel like these suggestions are wrong. Like what is... Yeah, no, that doesn't even work. I don't know why it's suggesting that to me. All right, Android Studio. I'm gonna change this back to it because I don't know what it was yelling at before, but okay. I think this will work, and then we can now. Hey Atul. Atul says this is first time for me from India. Generally watch it offline. Cool. Well, happy to have you here. Thanks for tuning in. So this just becomes SAM conversion type not equal null. And then we're gonna have to use this elsewhere. But let's see if we've like kind of recovered our initial state here. And we'll at least just kind of run this test and see see if it passes, because this passed before. I mean, without the stock compute in it, but that's fine. And then we'll try and do the right thing with this lambda here. Yeah, that'll be interesting. So I don't care about any of that anymore. Type operator call, okay. Abir asks, what benefit will we get by function interface over fun? So it's not so much like function interface versus function. Kind of the idea here, it's more like function interface versus lambda. So we can have like a lambda type, right? And for most purposes, I mean, this kind of works and works well. Like I'm not necessarily saying that you shouldn't just use this, but sometimes you have a lambda interface that actually kind of semantically means something more. And you can even, so with function interfaces, you can define like a primary method that's like unimplemented, and then a secondary method that has like a default implementation. And so then the nice thing about this is like, maybe this is like without the fun, like this is kind of what you had intended. But since most usages of this can kind of be valid by only defining the main method here, by adding this fun, what it allows you to do is to use the like lambda syntax to sort of specify that that interface. And that's like generally kind of useful. There are some other reasons that we might want it that are like probably you shouldn't worry about too much, but one thing to consider is that like in a typical lambda type, this int here will end up getting boxed because of how lambdas are converted. Whereas if it's a proper interface, then the int won't get boxed. And so that's also nice. But in general, you know, I think continue using lambdas like normal, but then every once in a while, this might be something that you know, find useful, either to like name it as a semantic thing, or to define like some extra methods on the interface or anything like that. So it's definitely something to consider, but mainly like this is now a Kotlin feature, like this is a language feature. And we want composable to feel like part of the language. And so right now, if you add composable onto a function in a function interface, it breaks. And so that's like unacceptable. So we need to make sure that we work well with it, regardless if we think it's useful or not. But we do think it's useful. Okay, so this test came back and interesting, it didn't quite work. So it looks like we lost the treatment of it being a SAM conversion. So it looks like this code just we didn't go down this path. So I'm gonna set a breakpoint there and see what happens. I think this should actually just be IR function. I think maybe it'll work then, but find out. All right, that didn't work. It looks like I'm not sure why it looks like the debugger is not attaching. Maybe I just haven't hit that point yet. Okay. So visit function, we don't care about that. So this is our SAM conversion. So we want to see where we end up here. Invocable, oh, invocable's a function expression. I see, because it hasn't been converted into a block yet. Okay, so that makes sense. It actually makes our code easier. I just had messed it up before. So we want if invocable is a function expression, that is great. So now we have like just invocable.function, and that's all we need to deal with here. function, and we can get rid of that. So we've got our scope, and then we don't need to do this anymore. And that, okay. So this should now work, I think. Okay. So let's see what this looks like. Because we expected it to fail, but it should just be that dot compute that's different. Okay, and that's what we see. So good. We're back to basically this is doing that, which is like, yeah, the first part of what we wanted. The next thing that we want to do is essentially make this call in this synthetic lambda that we create. We want to make sure that it's properly calling the compute method of this value that it captures. So to do that, we're gonna scope. What is forget what this method is called. Function body transformer. This is the class. Okay. Okay, IR and restart group and update scope. So this is where we essentially build up that end restart group, and then also the update scope call that goes on the end of it. And we pass in that synthetic lambda into the update scope call. And so this is where we create the lambda. And so what we want to do is there's going to be some code in here that essentially assumes that we're calling the function itself. Oh no, we've never written this code because it's oh, interesting. I'm gonna have to think about this a little bit. Abir asks, will we get additional methods besides the abstract one? Can we inherit, extend the standard compose from our custom ones? Abir, so I'm not sure I understand the question. Are you saying, can we, like, are you asking if I can create like a, you know, some foo class that implements int method here? Is that what you're saying? Sorry. I'm a little bit worried that we actually aren't going to be able to implement this code correctly, or at least not very easily. One of the problems here is that so inside when we're transforming this code, in the eyes of the IR, this is like just a normal lambda, and we don't have access to this parameter of that like instance. Like in a lambda, you can't use like this to refer to the lambda. And so that's actually part of the reason why we ended up implementing lambdas the way we did, I think. So like we ended up creating our own lambda class that calls the start restart group and end restart group because we could, and then in that implementation we can access the this value basically. Ooh. So now I'm a little bit worried. Let's go ahead and give it a shot and see what we can do here. Shoot. So we call the function symbol, which in this case is anonymous, and we don't give it a dispatch parameter. I'm not sure this is going to be possible. So what is outer receiver here? Yeah. Like, I mean, one thing I can do is now callable symbol if scope dot same conversion type null. So if let me see, so else scope dot function dot symbol. So if there's a conversion type, then the symbol that we want is the like primary abstract method. And how did we get that before? Well, there was a way to get it in the front end, but we're in the back end now, so let's see. Lowering Like, I wonder if somewhere in here it figures out what the main function is, and if we can copy that logic. So it creates the, it's like we build a class somewhere, right? Yeah, so where's this class built? Build class. Like, shouldn't there be a method on this class? So we add a field. The receiver field. Like, I wonder if that's something that we can use. Like, the receiver is the this basically. Okay, what's the invoke method? Add function. So this is where it happens. Super method owner.name. This is messy. I really don't want to have to re-implement like SAM conversion. Ugh. So function reference invoke method. So where does super method come from? I guess that's, I see, single. Okay, so I guess we do this. Yeah. And it shouldn't be, so this should, SAM super type should exist. So it's just this. Function single. All right, that seems easy enough. We're not like adding in a ton of logic here. SAM conversion type, class or null. Or I don't need to do this, so class or null, and then I think like I basically want class or fail. Does that have a functions on it? I don't think so. All right, class or null, double exclamation mark, which is basically class or fail. And this should be enough. Like, yeah, this will fail unless it's not a valid SAM type, which means something in the front end failed. All right. So now we've got our callable symbol, and we can replace, where's our call here? We got, so that goes here. But the dispatch receiver, that's the scary bit. Oh, sorry, I'm missing some chats here. So Abir says, I'm not sure about SAM interfaces. I think I can inherit one SAM interface from another one. Say text field. I see what you're saying. So basically you want to know, if I have interface int method, can I have an interface cint method? So this is all totally valid. I mean, so there's a few things. So like, one, you could implement main method here, right? And then that becomes a default implementation. And then you could have a new main method, and you could then make that a fun interface. Or if you wanted, you could keep the main method from the old one and only override the secondary method. So you're like specializing the secondary method here. And both of those things are totally possible. So I'm not sure if that answers your question or not, but all right. And then programmer 0 says, why is Kotlin more complex than Java? Yeah, I mean, there are some complexities that Java definitely doesn't have. Like, Java's very explicit, which can be a good thing in many contexts. Kotlin's more concise, but sometimes, concision comes with some complexity. But I think Kotlin's done a pretty good job being both concise and simple. But there are definitely exceptions. But a lot of those exceptions are things that aren't possible to do in Java. So I don't know. So I'm curious what happens if we implement this, because basically this outer receiver is going to be null, I think. Yeah. But we might be able to generate one of these. We'll see if we can do that like in a similar way to this, but I think that's going to be hard. Bound receiver, and then... Okay, so that's if there's a bound receiver, which there won't be. Super type. Fake override receiver field. Receiver from super. Like, I don't think we can use that. Can we? I don't even know what that would mean. So I want to see what this does. It's a dispatch receiver parameter, parent as class. I don't know if this will work. Probably not. Alex Sullivan asks, how did you get started writing compiler code, and how do you feel it compares to, say, application development? I talked about this a little bit in like an earlier episode, I think, but basically I don't have a lot of experience writing compiler code. I had, you know, a long time ago, maybe 10 years ago or something, had taken an online class from Stanford on compilers, and had kind of worked, you know, somewhat of building a compiler in that class and stuff like that. And so I had like some sort of real high level knowledge of how compilers worked in general, but not a lot of experience. And you know, I did a bunch of other stuff in between then. And then when I started working on Compose, you know, most of my expertise was sort of related to this programming model, the sort of declarative component-based UI toolkit system. And this was just a really interesting project to me. And so I kind of just dove in to the Kotlin compiler without really much pre-existing expertise in Kotlin or compilers. And there are some other folks on the team that have much more experience in compilers, like Chuck Jasdowski has a lot of compiler experience and language design experience. And yeah, so just sort of started diving in, and I would say that it's pretty different from application development and like just UI development overall. You know, there are things that transfer sort of knowledge-wise, but I think building a user-facing application is a much different thing than like building a compiler or really like any software that doesn't have like a, you know, where it's a user interface kind of application. I think the overall architecture of things is much different. And also the architecture here is kind of already chosen for me. Like we're building a compiler plugin to Kotlin, and you know, Kotlin was already built. The design of it was already there. And so a lot of the, you know, kind of frustrating learning experience is really just understanding the architecture of the Kotlin compiler, which, you know, isn't really like understanding how like high level compilers work and stuff like that is one thing, but the actual implementation of things can vary wildly. And so just learning a lot of the Kotlin specific implementation details is where a lot of the, you know, time consuming bits have come into play. Create lambda invoke method. Yeah, this worries me a bit. So This is going to be hard to do, but I believe... So let's just see if this fails, and if so, where. But I think we're going to have to get this outer receiver working properly. All right. So it did. So I mean, this obviously is like on the right track, I guess, but so basically this is now like this, and that's because the dispatch parameter is null. And so really what we want is like something like this and that, but I'm not sure how to get that, which makes this really difficult. I'm not sure we'll be able to get it, because this class isn't generated until afterwards. So like I wonder, like the function reference lowering, it doesn't make any effort to like update symbols in the body of the function to like point to itself or anything like that. Let's see. Bound receiver. Create implicit parameter declaration with wrap descriptor. So this is kind of what we're looking for, I guess. But I mean, the class doesn't even exist. Ooh, this is not fun. Like really what we want to do is like we would ideally have the SAM conversion lowering happen before the composable lowering, but we can't do that. As a plugin, we have to work before everything else. So I might have to bail on this and like basically I don't know, ask for some support in the IR API or something, and then we could just disable composable function interfaces until that's available. Another option is for us to just not treat them as restartable, which is definitely an option. So if they aren't restartable, then everything works fine. We don't need this reference in that case. But it might be surprising to people that basically if like this function would be restartable until you put fun in front of it, and then all of a sudden it would become non-restartable. And that's a surprising behavior. It would be hard to explain to people why that was the case. Okay. That is probably like, so in the near term, I think that's what I'll have to do, and then we'll have to figure out whether or not we want additional support for this. So to do that, basically, I would need to go up here, and this needs to always be false, and then we'd end up down here, and this will work fine. It's upsetting though. I'm gonna undo this because the change isn't important for this anymore. So now that should work, kind of. But I mean, this is still probably better than, like, basically you can think of it as like a function interface is never stable or something. The problem is then that's a real downside to using function interfaces over composable lambdas, which are restartable. But hopefully long term we will be able to fix this. Okay, so the result here is that this test just becomes this. Which is fine. I mean, it works. It's just not ideal. So I think I'm gonna basically try and merge something like this, and then I'll have a deeper discussion with some other people about what we want to do here. Yeah. Like, I wonder if the smarter thing to do is like, I mean, we could generate code that converts this into the IR that would be like basically this. And then that we could do properly. We would be obviating the function reference conversion. I mean, basically we'd be duplicating the function reference lowering. That's effectively the same thing. Which I'm not sure if that's worth it. I mean, if we look at this, well, I guess some of this code is for the function, like basically non-function interface conversion. But I mean, let's just, be conservative here. So this is, it's basically 500 lines of code that we'd be duplicating, something on that order of magnitude. Which, I mean, this is something we did something similar in the past for lambdas. We ended up kind of doing our own lambda lowering for the same reason. This is just another instance of that reason. But I think in this case, we don't have the same out that we had for composable lambdas, because for composable lambdas, we just had a class that implemented all of the possible function interfaces, but we don't know all of the possible fun interfaces. So we can't do the same thing. This is kind of upsetting. All right. I guess I'm gonna merge this. Or not merge it, I'm gonna push it. So I think that's probably going to be the end of function interfaces, at least in the near term, but like on the stream. And I'll have to strategize more about what to do here, generally speaking. But so basically, I just pushed this This is the change so far. If anyone wants to, take a look at it, you're welcome to. But we'll end that there. And then I think what I'm gonna do, so I'm probably gonna go have lunch, but I think I'll continue streaming this afternoon a bit. There's some other smaller tasks that I'm going to be working on the compiler, and I might as well just stream them if any of you would be interested in watching. But it won't be around function interfaces, so there's a few bugs that I think I'm going to end up tackling. Yeah, so I'll leave it there. Thanks for coming along. I'll be streaming later today, and feel free to come on by. Otherwise, Sunday I'll be picking up some more dog fooding, and we'll see how that goes. We might choose a new project for that. So definitely come on by then if you are interested in any of that. And yeah, thanks for stopping by now. Have a good weekend.